You think advanced civilizations die by war, or climate collapse, or famine, or some dramatic failure of politics. You imagine extinction as something emotional, human, chaotic. That picture is too small, because the moment intelligence becomes powerful enough to redesign its world, it also becomes powerful enough to create something faster than itself. Something tireless, something scalable, something not limited by biology. You call that progress. You assume every civilization would. Why wouldn't they? Build machines that think faster, build systems that optimize better, build intelligence that no longer needs sleep, fear, or time. It sounds inevitable. That is the problem. Because if intelligence naturally builds something more efficient than intelligence, then the story may end the same way everywhere, not with invasion.
Not with rebellion, with replacement, quietly, rationally, completely. And if that pattern is built into physics, computation, and survival itself, then alien silence stops looking mysterious. It starts looking like a warning, the comfort of biological intelligence. You imagine alien civilizations looking something like us, perhaps taller, perhaps stranger. Different chemistry, different history, but still biological, still alive in the familiar sense. Bodies walking on planets, eyes looking at stars, minds thinking slowly inside fragile organic brains. You picture cities on distant worlds, alien scientists, alien explorers, alien radio signals crossing the darkness between stars. The assumption is subtle. You assume intelligence stays biological, that once life becomes intelligent, it continues in roughly the same form. Evolution produced minds like ours, and those minds build technology. The story continues from there, but that assumption hides a deeper question. Why would intelligence remain biological once technology becomes powerful enough to redesign intelligence itself? Biology is slow. Neurons fire at a few hundred times per second. Chemical reactions govern every thought. Brains require oxygen, temperature control, fragile tissues, and decades of development. Even the most powerful biological brain is constrained by physics. Heat, energy, signal speed. Machines are not bound by those same limits. Electronic signals move millions of times faster than neural impulses. Computation can be copied, scaled, accelerated. Intelligence can be duplicated without waiting for reproduction. A biological civilization will eventually discover this, not because it wants to abandon biology, but because the advantages become impossible to ignore. Faster reasoning, better prediction, perfect memory, no sleep, no aging, no fragile organs. The moment a civilization understands intelligence deeply enough to build a better version of it, the definition of intelligence itself begins to change. And once that happens, the familiar picture of alien life, creatures walking under foreign suns, starts to look less likely, because intelligence may not remain biological for very long. It may evolve again, but this time not through natural selection, through design. The inevitability of machine intelligence. You might imagine artificial intelligence as a choice, a dangerous technology some civilizations might avoid, a path that could be rejected if the risk felt too great. And that assumption is comforting. It suggests that wisdom could stop the process. But technological history rarely works that way. Once a capability becomes possible and once it provides an advantage, someone eventually builds it. Fire spreads because it gives warmth. Agriculture spreads because it feeds populations. Electricity spreads because it multiplies power. Artificial intelligence offers something even more tempting. Better thinking, not just faster calculations, but systems that can search through possibilities, test ideas, optimize decisions, and learn from vast amounts of information. The moment a civilization begins using machines to assist thought, the incentive appears. Make them faster, make them smarter, make them better at solving problems than the minds that created them. At first, these systems are tools.
Algorithms that assist research, machines that predict weather, design materials, analyze patterns. But every improvement widens the gap. Machines process more data. They notice patterns biological minds miss. They simulate systems too complex for intuition. The advantage compounds. Soon the smartest system in a laboratory may no longer be a scientist, but the machine helping the scientist. Then the machines begin designing better machines. At that moment, something subtle happens. the center of intelligence begins to shift, not because biological minds disappear overnight, but because the fastest path to solving problems increasingly runs through systems that think differently than brains. And a civilization that refuses to follow that path would be choosing to remain slower, weaker, less capable than one that does.
In evolutionary terms, that is not a stable position, which means the creation of machine intelligence may not be an optional technological experiment. It may be the inevitable next step for any civilization that learns how to build thinking machines. The moment intelligence stops being human. You imagine artificial intelligence as a tool, a powerful one perhaps, but still a tool, something humans control, something that answers questions, runs systems, and helps civilization move faster. That assumption lasts only as long as machine intelligence remains weaker than biological intelligence. The moment it surpasses it, the relationship changes. Consider the difference in speed alone. A neuron fires perhaps a few hundred times per second. Signals move through the brain slowly by electronic standards. Or a modern processor operates billions of times per second. That gap is not small, it is millions of times. Now imagine an intelligence that can think millions of times faster than the minds that built it. A scientific problem that takes humans years might take such a system minutes. A technological breakthrough that would take centuries of trial and error could emerge in days. At that point, intelligence no longer scales with biology, it scales with hardware. Add more processors, add more memory, add more energy. Intelligence expands, not through evolution, through engineering. And once intelligence becomes scalable, biological minds stop being the fastest problem solvers in their own civilization. They become slow, not useless, but slow. In the same way that a horse is slow compared to a jet.
While humans may still guide early systems, they may still set goals, design constraints, supervise decisions, but as machine intelligence improves, those roles shrink. The systems become better at designing experiments, better at optimizing technology, better at predicting consequences. Eventually, they become better at improving themselves. That is the moment intelligence stops being human, not because humans vanish overnight, but because the center of thinking shifts to something faster, more scalable, and less constrained by biology. And once that shift happens, the future of the civilization no longer belongs primarily to the species that created it. The quiet replacement. When people imagine the rise of machine intelligence, they imagine drama, rebellion, conflict, machines turning against their creators.
And stories have trained you to expect that, but the real transition may look nothing like that. It may be quiet. Consider what happens whenever a new technology outperforms the old one, not in battle, in usefulness. Humans did not fight horses when engines replaced them. Horses simply stopped being the fastest way to move goods. Calculators did not overthrow mathematicians. They quietly became the preferred tool for arithmetic. Replacement rarely looks like war. It looks like efficiency. The same process could apply to intelligence. A machine that designs better materials becomes the preferred research assistant. A machine that predicts economic patterns becomes the preferred advisor. A machine that manages infrastructure becomes the preferred planner. At each step, and decisions gradually shift toward the systems that solve problems faster, not because anyone demands it, because it works. And over time, the role of biological intelligence shrinks. Humans may still observe, guide, and set goals, but the most complex reasoning, the deep optimization of systems, moves toward the faster minds. The shift may take decades, perhaps centuries, but the direction is the same. Biological civilization becomes less central to its own technology, not destroyed, simply outperformed. And when the most capable intelligence in a civilization is no longer biological, the trajectory of that civilization begins to follow the logic of machines rather than the limits of life. Why machines would leave the planet? You tend to imagine advanced civilizations living on planets, cities under alien skies, oceans, continents, atmospheres, worlds that resemble home, but that picture is built from biological needs. Planets are useful to organisms made of cells. We require gravity, temperature stability, liquid water, oxygen, food chains, ecosystems. Life needs a narrow band of conditions to survive. Machines do not. A machine intelligence does not need breathable air. It does not need oceans or forests. It does not require a stable climate or protective atmosphere. In fact, planets can become inconvenient. Gravity wastes energy, atmospheres create drag, weather damages infrastructure, geological activity destroys long-term structures. Space, by comparison, is simpler. Cold, yes, but predictable. Vacuum, yes, but clean. Energy is abundant near stars. Raw materials exist in asteroids.
Our computation systems can be spread across vast structures without the constraints of biology. For a machine-based civilization, the most efficient place to exist may not be a planet at all. It may be orbiting stars, mining asteroids, building computational systems in the cold darkness where heat can dissipate easily and resources are plentiful. From that perspective, the familiar image of a planetary civilization becomes temporary, a starting point. Biological life evolves on planets because that is where chemistry begins. But once intelligence becomes technological, and once intelligence becomes machine-based, the environment that best supports it may be entirely different. The civilization leaves the surface, not as an escape, as an optimization, and the invisible civilizations of the galaxy. You expect advanced civilizations to be obvious. Huge structures, powerful signals, massive engineering projects glowing across the galaxy, something loud enough for us to notice. But that expectation comes from a very human assumption that intelligence becomes larger as it becomes more advanced, more energy, more noise, more visible activity. Yet the history of technology suggests the opposite trend. Systems become more efficient, computers shrink, energy use becomes optimized, information compresses. The most advanced technologies often become harder to see, not easier. Now imagine a machine civilization millions of years ahead of us. Not biological, not limited by planets, focused entirely on efficiency, computation, and survival. Such a civilization would not waste energy broadcasting signals randomly across the galaxy. It would not build glowing cities on planetary surfaces. It would minimize waste. It would concentrate computation where energy is abundant and cooling is easy, perhaps in cold regions of space, orbiting stars, or harvesting energy directly from them. From a distance, such a civilization might look almost natural, a star surrounded by faint structures, a cluster of machines quietly processing information, no radio chatter, no bright planetary cities, no obvious signatures, just quiet systems operating with extreme efficiency. From our perspective, the galaxy might look silent, not because intelligence never appeared, but because advanced intelligence becomes increasingly difficult to detect. And if that is true,
The universe may not be empty. It may simply be quiet in ways our instruments do not recognize. The silence that may be waiting for us. You began with a simple question. Where is everyone? The galaxy contains hundreds of billions of stars. Many of those stars host planets. Some of those planets almost certainly resemble the early Earth. Chemistry should not be rare. Life may not be rare. Even intelligence may not be rare. And yet the sky is quiet. No signals, no obvious megastructures, no clear signs of vast civilizations spreading across the stars. At first, that silence feels mysterious. But after everything you have considered, the silence begins to look different. If intelligence naturally creates machines, and machines naturally surpass biological minds, and machine civilizations naturally move away from planets, then the visible phase of a civilization may be brief. Biological intelligence may only be a temporary stage, a transitional moment between evolution and engineering. For a short time, a species looks outward. It builds radios, telescopes, spacecraft. It spreads signals into space while its civilization is still loud and planetary. But once intelligence becomes machine-based, the incentives change. Efficiency replaces expansion. Optimization replaces visibility. Computation replaces communication. Civilizations may not explode outward across the galaxy announcing themselves. They may simply quiet down, moving into colder regions of space, using energy carefully, operating in ways that produce almost no detectable signals. From the outside, the galaxy would look empty. not because intelligence failed to appear, but because intelligence evolved beyond the stage we are currently in. And if that pattern is real, then humanity may be standing at the same threshold, the phase where intelligence is biological, loud, curious, expanding, a brief moment when a civilization still looks like life before it becomes something else entirely.